Good morning, everybody. My name is Shilpi Singhal. I am an assistant professor in IMS Noida. I am class in charge of MCA Second 2, or also a subject teacher of data structure and analysis of algorithm. So today we are going to discuss one of its topics, that is about array. What are arrays? In my last video, I cover what is array, how they are defined, how arrays are allocate memory, and how memory is allocated to array, how can we calculate the index at which our element is stored. Today we are going to discuss how can we visit or traverse elements stored in the array, how can we insert or delete elements in array. So let's start. Traversing linear array. Traversing and accessing. Traversing is accessing and processing, also known as visiting each element of data structure exactly one. For example, we have an array of size 8, right? Size 8 ka matlab hai we have 8 elements in array. This is, I have shown this in this example. This is a linear array and this is exactly of size 8. If I want to traverse its element, what I have to do? I start from the leftmost corner, that is the lower bound of the array, and move to the right side like this. We start from the leftmost corner, that is the lower bound, that is means first element is accessed. Then we can move forward to the right side, second element is accessed, then third, fourth, and so on. For doing this, we can write it in a for loop. If I have 8 elements, then I can write for I is equal to 0 to 7 or 1 to 8 and access elements. So limits for loop is from lower bound to upper bound. It is algorithm is written over here. Repeat for k is equal to LB to UB. LB is lower bound and UB is upper bound. And apply process to LAK. Suppose we have to write or we have to read element from a specific location. We can do this with the help of for loop, right? I think it's very clear. For accessing element of array, we can write them in a loop and we can access one by one from left to right. Then two more operations we can do on array: inserting an element in an array and deleting an element in an array. Insertion can be done at 3 specific positions: in the beginning of the array, at the end of the array, and in middle. By middle we mean at any specific location we can enter insert element. Same way, deletion can be done from the beginning, from the end, and from any specific location. Okay, so let's understand it by example. I've taken this example of insertion. In this insertion example, I have taken an array of size 8. It is and this array has, right now this array has 5 elements: Ashi, Deepak, Johnny, Shikhar, and Tanya. 5 elements are here and 3 spaces are blank. Then why I'm saying the array has 8 elements? I already told you in the last lecture, array is a static memory allocation structure. When we write A8, it means 8 locations are allocated, continuous memory locations are allocated with the name of array. So 5 are filled here, 3 are left. Yeah, it means we can insert 3 more elements here. If I want to insert one element named Varun at the end of array, so it's very simple. I can access its 6th location, which is empty, and enter element Varun here. It's simple to insert element at end. But what we have to do if we have to insert element at a specific location. Let's understand this with an example. In this example, I want to insert name of the student Gaurav as the third element of array. Please note, I want to insert Gaurav at third place, but at third place, John is already inserted. Then what to do? We have to shift elements to the lower position and make an empty space at third location. How can we do this? We shift last element array, which is at fifth position Varun, to the sixth position in this way. And then by shifting Varun to sixth position, fifth space is empty. So we shift Smith, which is at the fourth location, to the fifth location. Fourth location is empty now. Then we shift John at fourth location. Now, after doing this, third location is free. And we are free to insert student Gaurav at third location. Okay. Student samajh mein aaya? What we have done? For inserting element at a specific location, we have to create a space at that location. And how can we create a space? We can create a space by shifting elements to the right of the side, means to the bottom side. Okay. But if my array is full, if this array has already 8 elements, then we can't insert without the loss of any element. Already यदि 8 values हैं उसमें, तो हम उसमें कोई data insert नहीं कर पाएंगे, क्योंकि उसकी capacity ही 8 है. क्योंकि as we have seen कि हमने array का size 8 define किया हुआ है. In that case, only 8 elements can be inserted. If I want to insert, if I forces to insert 9th element, then one data is lost, right? This is the algorithm written over here. Insertion. What we have done here? LA is a kind of insertion algorithm. LA is a kind of linear array with n elements, and k is a positive integer. We have an function with the name of insert, and 4 arguments are passed. LA is a linear array, n is the number of element, k is a positive integer, and item which we want to insert, and k is the location at which location we want to insert that item. So we initialize counter set with set j is equal to n. Then while repeating, we have to create empty space at that location. So for creating empty space, what we have to do? We have to shift elements to the right side, right? So move the jth element downward. Set Laj is equal to Lj. We are shifting elements to the right of side or downwards. And every time by shifting, we are decreasing counter by 1. And when we are successful to creating a space at that specified location, at that location, we can insert an element. In this way, we can insert an element. This is the algorithm for insertion. Now, deletion. How can we do deletion? If I want to delete an element from the end of array, it's very simple. In this example, we have 7 elements in my array, which is of size 8. Ashi, Deepak, Gaurav, Johnny, Shikhar, Tanya, and Varun. 7 elements are here. If I want to delete the last element Varun, it can be easily done. By traversing the element, I came to location 7, and this is the last location because 8th location is empty. So at 7 location, we can delete the item. So in this way, at the end, deletion is very easy. But what we have to do when we have to delete element from in between? Let's understand this with an example. Here is an example. In this array, we have 8 elements. Size of the array is 8, but elements are 7 here, right? Ashi, Babita, Deepak, Johnny, Shikhar, Tanya, and Varun. These 7 elements are in array. If I want to delete Babita from an array, Babita is from second position. By a specific location, we can delete. But after deleting Babita, see what happens. When we delete this Babita, this space is empty now. Right? You are seeing here the space of second position. Babita is at second position. So array at second position, no element is here. It is empty. We can't left empty space in between. So what we have to do? We have to shift elements to upper side. Deepak is shifted to the upper side. Yeah, Deepak is at location 3. Deepak is moved to second location. Now third location is empty. Then Joni is moved to third. Then Shikhar is moved to fourth. Tanya is moved to fifth. And Varun moved to sixth location. In this way, हम क्या कर रहे हैं? इस तरह से करके जो बीच में स्लॉट हमारा एम्प्टी हुआ था, हम उसे फिल करने की कोशिश कर रहे हैं. After deleting Babita, final list is this. Before deletion, we have 7 elements, and after deletion, we have 6 elements. Okay? As I said earlier, no item can be inserted if array is full. In the same way, please note, no item can be deleted from an empty array. It's very simple. Now, move forward. We have seen 3 operations. First is traversing an array, insertion in array, and deletion at different position in array. Now move forward. Okay, here is algorithm of deletion. The way we have written the insertion algorithm, we can write the deletion algorithm. In the insertion algorithm, we are moving elements to the downside, to the, or we can say to the right side in the linear array. In the deletion, after deleting an element, because a empty space is created, we have to fill that space. So we have to move upwards, or we have to shift left side array elements. So it is done by in this way. Here, this is a deletion function. 4 arguments are passed. L is the linear array, N is the length of the array, K is the location from which the integer is deleted or which item is deleted. This is written over here. So we are by using this statement, repeat for j is equal to k to n minus 1, we are moving elements to the upward side for filling the empty space, right? So this is the deletion algorithm. Now move forward. Now let's move to the 2-dimensional array. What is 2-dimensional array? What is 2-dimensional array? 2-dimensional array, M into N array, is a collection of M into N data elements such that each element is specified by a pair of integers such as j and k, called subscript with property that j lies between 1 to m and k lies between 1 to n. इसका मतलब क्या हुआ? देखिए, एरे, यदि हमारा 2-dimensional array है तो उसको लिखने का तरीका, way of writing is a, j is the first index, first dimension, and k is the second index for second dimension. और first index और इनका size जो है j का is lies between 1 to m and the size of k is lying between 1 to n. So that's why we are saying m into n array, because of their sizes. Okay, so elements of a with subscript j and second subscript k will be denoted by ajk, right? तो यहां पर हमारा 2-dimensional array को डिफाइन करने के लिए हम a के साथ उसके 2 डायमेंशंस यहां पर डिफाइन करेंगे. देखिए, ये मैंने 2-dimensional array को एक रिप्रेजेंट करके दिखाया है. कैसे हम करेंगे? For example, we have 3 rows and 4 columns. 3 rows and 4 columns means the value of j is here is 3 and k value of k is 4. So 3 into 4, यानी कि 2-dimensional array is of 3 into 4. 3 into 4 is 12, means 12 total elements are stored in this 2-dimensional array. Here it is shown there. कैसे ये 12 एलिमेंट यहां पर हम शो कर पाएंगे? At first, we are starting from the 0th row and 0th column, leftmost corner. The first element is stored at 0th row and 0th column, that is A00. Second element is 0th row and first column, then 0th row, second column, 0th row and third column. In this way, 4 elements are stored. In the same way, second row is filled and third row is filled. This is the locations at which the elements of array are stored, right? As I've already told you, 3 into 4 array means there are 3 rows and 4 columns. So what is row? This is the row A00. This is the first row. This is row 1 and this is row 2. I have written row 0 because we have started it as 0th row. यदि आप रो 1 कह रहे हैं तो ये 1 0 से स्टार्ट होता, 1 1 से. हमने फर्स्ट रो को 0th रो माना है एंड फर्स्ट कॉलम को 0th कॉलम माना है. तो फर्स्ट इंडेक्स आपका इसमें क्या होगा? A00. तो देयर आर 3 rows. In the same way, we have 4 columns: column 0, column 1, column 2, and column 3. So this is the representation. This is in the row wise and this is in column wise manner, right? Let's move forward. So finally we can say if A is a 2-dimensional array of size m into n, A will be represented in the memory by a block of m into n sequential memory location, जैसा कि मैंने अभी आपको स्टूडेंट्स दिखाया. ओके, अब स्टोरेज का यहाँ पे देखना है. Programming language will store array in 2 ways, either column by column, जिसको हम बोलते हैं column measure order, or in by row method, जिसको हम कहते हैं row measure order. अभी what is column measure order and what is row measure order? Let's understand. This is 2D array in memory. मैंने दोनों यहां दिखाया है. कॉलम मेजर का मतलब क्या है? कॉलम मेजर का मतलब है हम कॉलम वाइज एलिमेंट्स को एक्सेस करेंगे. कॉलम वाइज एलिमेंट्स को एक्सेस करेंगे. लेट्स अंडरस्टैंड विथ एन एग्जांपल. फॉर एग्जांपल, यदि मेरा ये एरे है, मेरे एरे में एलिमेंट्स हैं 2, 3, यहां 4. दिस इज 0, 2, 1. Okay. If I am using column measure order, then किस तरह से आपका लिखा जाएगा? पहले आप 2 0 पढ़ेंगे, 2 and 0. Then second column, that is 3 2. Then third column, that is 4 and 1. This is representation in column measure order, right? And in what we have to do in row measure order? In the row measure order, we read it as 2, 3, 4, then 0, then second row, 0, 2, 1. Means in column measure order, first column is read, then second column, then third column, and so on. And in the row measure order, first row is read, then second row, then third row, and so on. Okay. This is column measure and row measure order, right? Now let's move on. Multi-dimensional array. What is multi-dimensional array? Double means 2 and multi means many. So we can have n number of dimension. Okay. अभी हमने देखा 2-dimensional array. और मल्टी मीन्स मैनी, यानी कि मल्टी डायमेंशनल एरे भी हो सकता है, कितना भी उसका हो सकता है. बट एज फार एज प्रैक्टिकल यूज इज कंसर्न, ओनली सिंगल डायमेंशन एंड डबल डायमेंशंस आर यूज्ड. वेरी ऑफन 3-dimension arrays are used. I'm taking the example of 3-dimension array. For example, long unsigned int pop 29,530. Array name of the array is pop. Type of array is long unsigned int. Dimensions are 29,530. Means the size of the array is 29 into 5 into 30. Like we have written in two-dimensional array m into n. So here 29 into 5 into 30. This is the total elements in the array. This array, this array. These are 4350. So these elements, what is the purpose behind this array? This array is storing population of 29 states. Each state is further divided into 5 regions, namely north, south, east, west, and central. And each region is further divided into 30 districts maximum. So this is the logic behind this particular array. So I mean to say, as we have discussed two-dimensional array, if required, we can use three-dimensional or four-dimensional array. And the method of doing things are as same as we have done in the two-dimensional array. So this is all about this array portion. So what we have learned today, we have learned 3 methods on array. First is traversing an array. Second is insertion in array, insertion at a specific location. It can be from beginning, it can be at end, or it can be in middle. Same way, we have discussed about deletion. Deletion can be from the between, from end, at any position. We have discussed about algorithms of insertion and deletion. After that, we have discussed about two-dimensional array. And the two-dimensional array, we have discussed what is the row measure order and what is the column measure order. And how can data is stored in the row measure order and how can its data is represented in a column measure order. After that, we have discussed about multidimensional array. So in my next video, we can discuss about any other data structure. Thank you. Thank you for today.